Shelby posted this yesterday, whatever. Anyway, an AI model called ESM3 simulated 500 million years of evolutionary processes to design a new protein called ESM-GFP. Okay. All right. An AI model, blah, blah, blah. That's the whole thing. So the fluorescent protein, similar to the proteins found in jellyfish, could have applications in medicine. Okay. All right. You following me so far? It exists only as a digital sequence right now and differs significantly from known proteins. Researchers from the company Evolutionary Scale published the results, which are now peer-reviewed. Novel protein engineering could revolutionize many areas, including the development of new drugs. Fluorescent proteins such as ESM-GFP are already being used in research to visualize biological processes, and et cetera, so on. Anyway, there's the headline. Okay. Now, the wild part about this is when you think about, again, medicine at scale. I've been making the joke of the everlasting gobstopper recently, right? The fictional Wonka candy that you could, it will never disappear. You could have the gobstopper in your mouth for eternity. Okay, clearly ridiculous and funny, and it's a great name. Okay, clearly, what was the guy trying to get the everlasting gobstopper? What can I say it? Recipe. What was his name? The guy that was chasing him around trying to get him to sell out Willy Wonka. Anyway, I can't remember the guy's name, but fantastic plot line. Anyway, I digress a little bit there. But the joke of the everlasting gobstopper is that it was a magical thing. It was a magical element, this candy in this case, that was created by Wonka and the factory, okay? Well, we'll get to more of that because there's other magical candies in pop culture and, of course, fiction and some other wild ideas that come as part of this. But when you look at the headline, right, this, to me, stands out because we're talking straight up new glowing molecule invented by AI would have taken 500 million years to evolve in nature, scientists say. And this is the wild part, is if we're creating this or actually on the cusp of creating these things and sort of bypassing that evolutionary process, things get incredibly weird because not just the everlasting gobstopper, as I've been describing, again, that's a metaphor, but in the case of, let's say, personalized medicine, creating proteins that have never existed on this planet. So we're actually talking alien life, okay? In some capacity, alien life. And being able to, what would you call it? Simulate 500 million years of evolution to create such a thing. Well, it's just a protein, right? This is where it starts. It's just a protein. And so it's not going to, stand up and become a swamp monster tonight or something. But what happens at scale, okay? Is it going to be possible? So I want you to think about this. At scale, what does this mean? If you can simulate 500 million years of evolution in an AI system and create a new protein that is alien to this earth, are we going to be Slugworth? That's the guy. Thank you. Slugworth. Yeah, that's the name I was looking for. But if you're able to do this and create this alien life, because this will be eventually alien life, something that has never been on this planet before, what are we dealing with here? Okay. And will you be able to sort of conjure through the magic and science of modern whatever's about to happen? I'm calling it spells of science tonight, the new age of molecular magic. And that's the point, molecular magic here, because I think that's what we're dealing with. And this is what that looks like at scale. And is it going to be possible to literally build a swamp thing or build you name it, like a centaur, or I don't know, you tell me, like sort of take what you need, scale it out, go back in evolutionary time conceptually, and then evolutionize, is that a word? Forward to create an entity, to create whatever you want. A little gray alien, little green men, whatever, right? I mean, suddenly, like I said, and so when you start with just the idea of medicine and they're saying that there's going to be a pill to cure cancer, a one shot. Oh, well, you got the thing. Sorry about that. Take this, call me in the morning. Take 2 of these, call me in the morning, right? That whole bit. But in this case, now we're talking not just proteins, but of course, well, if you can skip 500 years of evolution and snap your fingers and do it in a week, suddenly we're looking at a future that seems very much magical. And so I want you to think about this as we take a quick break here and get a word from our sponsor. What does this mean for the future at scale? Because right now, it's just a protein. New glowing molecule invented by AI would have taken 500 million years to evolve in nature, scientists say. I'll read you a little bit from the article so you are filled in on exactly how they kind of did this, and then we'll talk about it. Think about it. What does this look like at scale? Not just personalized medicine, curing the ends of ends, but also this could create nightmares. You get it? As always, there's two ways to look at things, and so that's what's on my mind tonight, looking at this glowing molecule, 500 million years of evolution, and, well, a conversation. So artificial intelligence, of course, in this case, has taken a leap into the biological domain by simulating 500 million years of molecular evolution to create the code for a previously unknown protein new to this earth. Researchers call this synthetic creation ESMGFP, as I was saying, and it bears a resemblance to the green fluorescent proteins found in glowing sea creatures like jellyfish and corals, hence the weird image you got back here of the sea monster coming to life. Anyway, instead of waiting for nature to make these slow evolutionary leaps, an AI model known as ESM3 filled in genetic gaps to design something new. The final blueprint differs enough from its closest natural relatives that it's as if ESM3 jumped straight to a biological innovation that would have taken hundreds of millions of years to appear on its own. Weird, right? The process behind ESM3 involves learning the fundamental rules of protein biology. Researchers fed the model data on the amino acid sequences, structures, and functions of billions of known proteins. When ESM3 was shown an incomplete protein blueprint, see, they kind of left some pieces out like a puzzle, right? It guessed the missing pieces by drawing on its understanding of how real proteins evolve. Its generated code eventually produced a glow-in-the-dark protein never before seen in nature. This so-called problem-solving approach isn't fully constrained by the usual pathways of evolution, allowing the AI to come up with unconventional solutions, like a futuristic inventor that knows no bounds. And this is the point, right? When you talk about these ideas at scale, can you create, I don't know, like you guys know I'm a fan of Dungeons and Dragons. Can you create monsters, mythical monsters from the monster manual? Can you create mythical monsters from folklore? With this idea, again, 500 million years of a protein, now scale that. Could we talk billions of years of an entire life form? Reverse engineered? Maybe. Maybe. What does the next 10 years bring? Golems? Yeah, elementals, you name it, right? The swamp thing, like I said, all manner of ways to look at this. And does that sound even possible to you? That's the wild part about this, because this, of course, makes my tinfoil tingle. And I'm not sure if clearly I'm prone to overreact to this AI news because it's coming so fast. It's incredible. So maybe, right? I mean, maybe. As usual, great time to drop all the disclaimers. There's no truth to be found here, okay? Just the article there that I'm citing, and everybody else gets the benefit of the doubt for truth. Me, I'm not here to tell the truth. I'm here to talk ideas, to consider possibilities, and to wonder about, let's say, mythology, folklore, and futurism at scale and what it means to be human. So if you're here for truth, you're in the wrong place. We're just here for ideas. And that's exactly why I talk about this stuff in the way I do every single night, which, by the way, we are including you as part of the conversation. If you want to be part of it, 702-957-1037. You can click the Discord link at troubledminds.org or troubledminds.net. They're both back up and working. .org is loading a little slow on the episodes. I'm still working on that, but everything's back up properly. And you can go join the Discord and find the phone number, troubledminds.org or troubledminds.net. Anyway, so skeptics of this point out that ESM3's claim to simulate eons of natural selection only covers the changes in a single protein, which was my point when I'm talking about this at scale, right? So the skeptics are discussing this. True evolution is a multi-layered process, of course, that spans entire ecosystems, peppered with unpredictable forces and countless twists and turns, like we've talked about quite often. Yet this doesn't diminish the achievement, all right? This is right from the write-up. It prompts questions about the future of biology when human-driven innovation meets nature's own creative powers. AI can do in mere days what took billions of years in the wild. And this is my point, leaving many to wonder if we're stepping onto a technological path that nature itself may have never taken, which means, okay, so if you can scale a protein and go back 1 billion years and fill in gaps and kind of make it, I don't know, like seed it with a partial something, and then have it kind of create its own evolutionary path, then suddenly, and then give us the proteins, the actual, let's say even a DNA sequence, eventually a full DNA sequence of a centaur, for instance, or a satyr, or you name it, like a Pegasus, or right? Like, skip flying cars, forget that nonsense. I don't want a flying car. I want a Pegasus. Hell yes, get me one of those, right? Like if we're on the cusp of this stuff. But again, like I said, let's not get ahead of ourselves and let's not get too excited. But the question for you guys tonight is, do you think that's even possible? It seems impossible to me. But are we on the cusp of achieving the impossibility of the notion? And that's why I'm here to talk about these ideas, right? Skip that nonsense. Just give me the centaur. So, of course, the speculation here doesn't end with pure science. Some theorists ask whether these engineered proteins might affect human consciousness, which, of course, as you would expect, is going to come into this conversation, especially if we someday integrate them into neurons or use them to manipulate chemical signals in the brain, for instance. Others see a conspiracy angle, you don't say, right? Fearing that advanced AI systems could be used by unseen forces to guide evolution under secret agendas, which again has always been at the forefront of these ideas, because you never really know what comes next. Okay, when it comes to, I don't know, the past several years taught us something. Taught us a lot about propaganda. It taught us a lot about sort of our own fortitude. Taught us a lot about peer pressure. It taught us a lot about some wild ideas, which we're supposed to trust the experts and all the rest of that stuff, right? Well, I'm not going to delve too deeply into all that. We did many shows on that, sort of in the periphery. Like I don't, me, I kind of dance around. I dance around the idea and talk about it, but you know exactly what I'm talking about. So in any case, back to this. So if we can do this now again, going back literally hundreds of millions of years to sort of fill in the gaps of a protein that does not exist yet on this earth. So now it exists, and it kind of evolved artificially, of course, through a simulated space. So again, it's not real. It's not real. However, you think they're trying to make this thing? You think they're actually in a lab, petri dish and whatnot? You're like, okay, well, we got the sequences now. Let's try and put this thing together. Let's create this. Let's create this thing that has never been alive or even dreamt of being alive on planet Earth. You get it? Certainly, of course, this will scale. Eventually, again, and let's hope for the best. Cross your fingers. Nobody knows what's coming. The next 5 to 10 years are going to be incredible. We have no idea. And some suggest the end is nigh, right? Where's my end is nigh sign? I need one of those to hold up while I'm doing the end is nigh. The end is nigh. I need a bell to ring or something, and like a bullhorn. There's always people that are talking about that stuff. And especially with AI, as it accelerates, we don't know what that means. Nobody knows what that means right now. There's a lot of ideas. There's a lot of speculation. There's a lot of theories. And there's a lot of trepidation, because building these things and then scaling them out means that we need to put a stranglehold on it of control. And scaling something smarter than yourself, well, is going to be very difficult to control, especially if you're talking all these different labs doing it all over. We talked about DeepSeek recently, but by the way, DeepSeek is a CCP outfit. So I encourage you guys to use DeepSeek. Last time at the end of the show, only if you want to give China your direct information. There are ways to run it locally. I'll inform you on that as we go. And anyway, so just so you know, they're definitely collecting our data as part of it. But okay, so back to this. Now I'm calling it tonight the show Spells of Science, because that's exactly what this is. A literal new age of molecular magic. If you talk about alchemy, if you talk about evolution, if you talk about DNA sequencing, if you talk about gene splicing and CRISPR and all this stuff, right? Suddenly, these ideas that have developed, at least us sequencing the DNA, human strand, and all the rest of that stuff, the genome, if you've done all that, okay, and we're told science has done a lot of that, then what comes next? At scale. Put your foot on the gas, close your eyes, and dream of what might come next. Because I'm telling you, the possibilities are absolutely endless. And if you want to merge reality with some other aspect of I don't know, but like I said, a unicorn or a Pegasus, is this stuff possible? Maybe. maybe not. And that's again where the dreaming comes in. I'm not a scientist, so I can't speak to that directly. I know this is brand new technology, just like last time we did brand new cosmic, the framework of the cosmos or whatever, the substrate. So is it possible? Like think about this, how cutting edge science is really rubbing up against, dare I say, God himself. Small g, God. Okay? The gods, demigods, whatever you want to call this. Not trying to be blasphemous. I'm just saying that if we can create life and simulate evolution to the point where we're creating not just proteins to begin, but suddenly DNA sequences of individuals, critters, things that never existed on this planet, or maybe did, and we can resurrect. Think back to ancient astronaut theorists say yes, of course. Think back to the pyramids, and think about Horus with the falcon head, and think about, right, Set with the dog head. I think I got that right. No, Anubis with the dog head, right? I mean, are we going to be able to do that? Yeah, bumping elbows with the gods, exactly. I don't know. Like I said, when you think of this at scale, I don't want to say terrifies me, but it does make me go, what comes next? Here's the abstract on that. So I'm going to read you the quick abstract on this science paper. Links are in the description, but check this out. More than 3 billion years of evolution have produced an image of biology encoded into the space of natural proteins. Here we show that language models trained at scale on evolutionary data can generate functional proteins that are far away from known proteins. We present ESM3, a frontier multimodal generative language model that reasons over the sequence, structure, and function of proteins. ESM3 can follow complex prompts, combining its modalities, and is highly responsive to alignment to improve its fidelity. It sounds like it's ready to scale. They have prompted ESM3 to generate fluorescent proteins. Among the generations that we synthesized, we found a bright fluorescent protein at a far distance, or 58% sequence identity from known fluorescent proteins, which we estimate is equivalent to simulating 500 million years of evolution. Seems fine, right? It seems fine. Everything's fine. Everything's going to be just fine. I'm telling you, though, in the next 5 to 10 years, it's going to be off the chain. How wild is this? Am I too hyped for it? Am I right? Am I wrong? And that's okay. My whole point of being here is being wrong. So if you think I'm wrong, that's okay too. But spells of science. Think of this at scale. Think what happens given ever increasing compute being cheaper and cheaper and cheaper. And so scale ends up being negligible, right? I guess in that sense. I don't know. It's wild to me. I don't know the answers to these questions, but I do know that we are on the cusp of Lord knows. Tonight, we're wondering about spells of science, the new age of molecular magic. Could AI truly engineer proteins that not only mimic but surpass nature's designs, leading to personalized medicine, space adaptation, or even mythical creatures? The convergence of biology and technology might just redefine the boundaries of what's possible, and we might actually be on the precipice of said possibility. Wild stuff, right? We're going back to this article where we started. ESM3, simulating 500 million years of evolution with a language model, seems wild, right? I think, and for the record, I'm going to say I think there's a little bit of human hubris baked into this, because there's always going to be, right? There's always going to be. We think we can do godlike stuff with some technology, and I'm not so sure. I'm not so sure. So there's going to be, right, aside from the wow, holy moly, that's a big number, 500 million years of evolution. There's also that human hubris effect that we bump into when we start dreaming as if we are the gods themselves. I don't know what your take on this. Lots of ways to look at this. Am I going to get a Pegasus before I get a flying car?